Hello everyone. Today we will talk about how we build an XOR gate while collaborating with three other teams. But first of all, what is an XOR gate? Well, XOR stands for exclusive OR. To understand XOR, we first need to understand the OR gate. An OR gate, as its name suggests, gives a true output if at least one of the outputs is true. The key phrase here is at least one. If you look at the truth table, especially for the fourth row, you can see that when both inputs are true, the OR gate still gives true as the output. However, in some situations, we only want the output to be true when exactly one input is true. We don't want the output to be true if both inputs are true. In this case, we use exclusive OR or XOR gate. As you can see from the truth table, the XOR gate gives false when both inputs are true. Now that we understand what an XOR gate is, the next question is, how can we build it? But before explaining that, let me introduce our groups.
Rehberimiz Salih'ti, sintezde valihti, müşahitte içindi, buna arada pervildi, hey!
Now let's begin. These are OR logic gates, not AND, OR and AND gate. The second AND gate will join us later. Don't worry about it for now. First, we connect the AND gate and the NOT gate. We remove the power supply from the NOT gate and the lead from the AND gate. Then we connect the output of the AND gate to the input of the NOT gate. By doing this, create a NAND gate. After connecting them, we test the circuit. It seems to be working correctly, so we can move on the OR gate. We follow the same steps as before. We remove the push buttons because we will use the inputs from the AND gate's push buttons. And we connect the power supply from AND gate to OR gate. After connecting everything, we test it again to avoid any surprise at the end. It's working.
A few moments later.
Now we finally bring in our second AND gate. Again, we follow same steps. We remove the push buttons and the power supply. And because of the distance between components, I need to use jumper wires to complete the connections. Now our XOR gate is fully assembled. Let's test it. The LED turns on when I press only one button. When I press both buttons, the LED turns off. Yes, our XOR gate is working.
Team number 5.
Team number 4.
Team number 8.
Now let's understand why it works. As I mentioned earlier, our XOR gate is built using 4 gates: AND, NOT, OR, and another AND gate. Let's analyze different input case. First gate. When both inputs are 0, the first AND gate receives 0 and 0, so its output is 0. The NOT gate then inverts this 0 into 1. At the same time, the OR gate checks the inputs. Since both inputs are 0, the outputs 0. Finally, the outputs of the NOT gate and OR gate are connected to the final AND gate. Since one input is 1 and another input is 0, the final AND gate output is 0. So the lamp stays off. Now let's look at the case when only one input is 1. The first AND gate output is 0 and the NOT gate converts it to 1. The OR gate sees at least 1, so its output is 1. Now the final AND gate receives 1, and therefore its output is 1, and the lamp turns on. This is exactly what we want from an XOR gate. The output is 1 when only one input is 1. Finally, let's see what happens when both inputs are 1. The first AND gate outputs 1, and the NOT gate inverts it to 0. Even though the OR gate output is 1, the final output becomes 0. So the lamp turns off, and this is why our XOR gate works correctly.